Dear Alex, again, now this will be the last podcast for today. So this will be showing you the example 10, the photo shaft design, photo examples of the shaft design due to bending, combined bending and twisting moment. So here's the question. Now this is quite a lengthy question. Now a shaft is supported by two bearings placed 1 meter apart. So, a 600 millimeter diameter pulley is mounted at a distance of 300 mm to the right of the left-hand bearing. So I repeat the questions again with the diagram. A shaft is supported by two bearings placed 1 meter apart. So this is 1 meter apart. Okay. A 600 mm diameter pulley, that is pulley C here, is mounted at a distance of 300 mm to the right of the left-hand bearing. So this is the left-hand bearing to the right. So here you have 300 mm, the distance here, or 0.3 meter. And this drives a pulley directly below it. So you have another pulley that is directly below this. So that is why it's giving you two vertical tensions, T1 and T2, because the pulley is driving another pulley below it with the help of belt having a maximum tension of 2.25 kilonewton. So that's the tight slide tension for the pulley of 600 mm. And then another pulley of 400 mm, that is this, diameter is 400 mm diameter, is placed 200 mm to the left of the right hand bearing. So this is the right hand bearing to the left. So it is 200 mm. And is driven with the help of electric motor and belt, which is placed horizontally to the right. So you have a horizontal, direction of force. That means the tight and the slack side should be acting right hand side towards the right horizontally, because you have another pulley here. Okay, so that is why I draw T3 and T4 facing this direction, and it's horizontal. Okay, and it's driven with the help of electric motor and belt, which is placed horizontally to the right. The angle of contact, or the angle of lap between the belts, both the pulleys, that means for both the pulleys the angle of lap is 180 degree, and the coefficient of friction is 0.24. Now find or determine the suitable diameter for a solid shaft. So we are actually considering a solid shaft, allowing working stress of 63 megapascal in tension, that is the normal stress or the bending stress, and 42 megapascal in shear for the material of the shaft. So in this case, you have to you have to consider both the ME and the TE. Now assume that the torque on one of the pulley is equal to that of the other pulley. So you assume that the torque transmitted is actually the same between both the pulleys. So I have shown you here for these questions here, I won't be putting in the values. I will be explaining to you step by step how we're going to do it. Okay, so the first step is to draw. Now we have already drawn the space diagram according or based on the questions that is given here. Okay, so this is the first thing you must do, draw the space diagram. The second thing is, now step 2, based on the maximum tension of 2.25 kilonewton, that is this, vertical, and the angle of lap of 180 degree between the T1 and the T2, so the angle here should be 180 degree. Okay, and to be converted to radians, and the coefficient of friction is given as 0.24. Okay, use belt tension ratio, the formula that we have learned from mechanics of machines, to find the slack side tension. That means to find the T2. So you can take the belt tension ratio, Tmax to Tmin. Usually we refer to Tmax to Tmin. That is T1 over T2. Tight side tension, slack side tension equals to the exponential of, this is the coefficient of friction, and this is the angle of lap, which should be in radians. So step 3. Okay, once you have got T2, then you can substitute here, to find out the total weight, because when we look at the side, from the side view, we have both the tension which is acting vertically downwards will actually give you a total vertical force or load which is acting vertically downwards that consists of T1 and T2. Now all forces or loads must be calculated before proceeding to the bending moment. So please calculate the T2 here, and please calculate the total load here. So step 4, calculate the torque transmitted. Now we know that based on pulley, as I have explained from the previous example, you can take T1, T2, T3 and T4. They are as tangential force. So this tangential force T1 and T2 is actually based on the larger pulley. So the radius here should be 0.3 meter. So the radius here should be 0.3 meter. So that is why I said you must find out T1 and the T2 first. The T1 is given, so you use this to find out the T2. So from here you will be able to find out the torque transmitted. And don't forget, the questions has already said the torque on one pulley is equal to that on the other pulley. So the torque is to be the same. So from that, you have this equation, and based on the belt tension ratio, now this time you take T3 to be the maximum and T4 to be the minimum slack tension for the smaller pulley, which the tension is acting horizontally to the right. So you have T3 over T4, T max over T min equals to E mu theta again. So based on this formula here, look at my laser pointer, based on this formula and this here, you will be able to find both the unknowns, that is T3 and T4. Sure, the torque we have already found, that is based on this. So the torque, and then you have T3 and T4, radius is given, mu is given, theta is given. So the unknowns on both the equation is only T3 and T4. So we'll be able to find out the T3 and the T4. So then, after that, step 5, what you need to do is draw the torque diagram to show that the torque is constant between the two pulleys C and D. So this is the torque diagram, which gives you 357.6 Newton meter. So that means the torque that you have found here is 357.6 Newton meter. So draw the torque diagram. Then step 6, calculate the total vertical load, which we have already calculated just now, vertical load that is based on T1 plus T2, and the horizontal load that is based on T3 plus T4. These two forces here are acting horizontally, towards the right. So the total load between the two forces will be, WH. It will be denoted as H. Vertical will be denoted as V. Horizontal denoted as H. So the next, so that is what we have drawn earlier. So the next step 7, draw the vertical load diagram. So based on this diagram, remember, pulley C is only the vertical loads, pulley D is only the horizontal loads. So when they ask you to draw vertical load, that means you only look at pulley C itself. So you have a vertical load, that means your T1 plus T2 should be equal to 3308 Newton. So that is the free body diagram based on any vertical load that is acting on this. So that is only on pulley C, not on D. D, remember, is horizontal. So for vertical load, you have only this force here. Then the step 8, draw the horizontal load diagram. But this time, we don't look at pulley C and only D here. So remember, this is vertical. Then the next one is to be the horizontal load diagram. That is only at pulley D. So T3 plus T4, you should get 4964 Newton. That should be the answer. So you have vertical load diagram and horizontal load diagram. So both of these diagram, or both of these free body diagrams, you don't have reactions at A and B here for both the case. So what we need to do is we need to find out both these reactions here based on vertical load diagram and the horizontal load diagram, the free body diagrams. So step 9, based on vertical load diagram, find the reactions at both end supports using this formula, this condition here. Total vertical load, that means you only consider this, and this, and must be, another condition, which is a summation of vertical bending moment. Either you take point A or you take point B as your reference point to find out the bending moment, to calculate the bending moment, and you will be able to find one of these force here, A or B. So if you take moment about A, of course you will find B, and if you take moment about B, you will be able to find the RAV. Okay, so step 10, based on the horizontal diagram again, okay, find the reactions, the same thing, but now this time is based on the horizontal load diagram. Find out these two reactions here based on the condition, taking moment about this point here. So you have 4964 multiplied by this length equals to this reaction multiplied by this length. So you will be able to find out RB if you take moment about point A. If you take moment about point B, you'll be able to find out RA. So the next condition is you have to consider the total forces acting in horizontal direction, because pulley D is horizontal. So you will be able to find out the other reaction. So after that, okay, you have found the RAV, RBV, RAH, and RBH based on step 9 and step 10. Then step 11, find and list down all the bending moment at each point starting from A to C, A to C, A to C, A to C, and then C to D, D to B for vertical, and then list down the bending moments from A to C, C to D, and D to B for both the cases separately. Okay, please work it out separately, the bending moment for the vertical load diagram and the horizontal load diagram. Okay, so based on that, you will be able to find out the bending moment for these cases here, A, B, C, D, and A, B, C, D here. So based on the list of bending moments values, or the magnitudes of the bending moments that we have found based on both this diagram, then we will be able to construct the vertical bending moment diagram and the horizontal bending moment diagram, which is shown here. So based on the vertical load diagram, you will have bending moment at A0, bending moment B0, bending moment A0, bending moment B0, bending moment at C is 694.7. If you were to follow step by step, and you can take one of the example I've shown you how to calculate bending moment from point to point. Just refer to that, and you will be able to find 694.7 at point C and 198.5 based on point D, okay, the bending moment diagram based on vertical load diagram. Then the next is based on the horizontal load diagram. Okay, you will be able to find the next, or you will be able to draw the next bending moment diagram that is at D, because the force for horizontal load diagram is acting at D. So from there, we will be able to justify that, or we will be able to assume that the bending moment at point D should be larger. So here, 794 at point D, 297.9 at point C, okay, where A and B are zeros. Then, based on both of these diagrams, you have to work out the resultant bending moment by taking 694.7 here square plus 297.9 here square. Okay, you have to add both of these square here, square this plus square of this, then you square root it, then you will be able to find out the resultant based on these two values, and also the resultant based on these two values as well. Okay, so step 13, calculate the resultant bending moment based on the vertical and the horizontal bending moments that we have found on each point. Then you'll be able to draw the resultant bending moment diagram based on those values. The maximum resultant bending moment is chosen for the design of the shaft from here. So from these two cases, we will choose 819.2 Newton meter. So that is the maximum bending moment. Then step 15, with the maximum resultant bending moment and the constant torque, the torque. That means in this case here, in this question, you actually have already found out the maximum bending moment M, and also have already found out the torque. Then you can proceed with the design of the shaft diameter based on the maximum allowable bending stress, tensile stress that is given, and based on the maximum shear stress which is given. So it depends on you whether you want to start from with TE or ME first. Okay, so find the diameter of the shaft using TE and ME. So TE when maximum shear stress is given. So you have to consider TE when maximum shear stress is given. And you have to consider ME when maximum bending stress is given. But in this case, both the shear stress and bending stress is given. They are given. So you have to use both TE and ME. So if both bending and shearing stresses are given, both TE and ME must be considered, then the maximum diameter being considered, okay, for the case to withstand both the stresses. Okay, so you have to make use of these two formula here in order to find out the diameter of this and the diameter of this. So after we have worked out the diameter for under the condition of TE and the condition of ME, diameter, both diameters here, so you have to choose the maximum value of these two. That will be your answer. Thank you very much. That's it. That's all for the slide or this podcast for today. Thank you very much and hope to see you soon. Thank you. Please put your comments on my YouTube channel under the section of shaft design. Thank you very much. Thank you for the supporting. Thank you and see you all soon. Bye bye.